Hello everyone, welcome back to JDCodebase. So this is our DSA foundation series, and today we are going to learn something very important, that is the array patterns. Now listen carefully. DSA is not about solving random problems, it is about recognizing patterns. Once you understand their patterns, you do not need to memorize 100 problems or 200 problems. You just apply the same thinking again and again. Today we will build three very powerful patterns. First one is the track maximum minimum, and the second one is the count frequency. Third one is the prefix sum idea. It means I'm not going to thoroughly to this prefix sum, and then we will solve two small practice problem in this in the last of this video. If you are a beginner, don't worry at all. We will go step by step. So what you will learn in this video. Today we are not solving heavy pattern problem. We are building the thinking habit. By the end of this video, you should be comfortable with the finding the maximum and minimum, counting frequency using the object, understanding the prefix sum, and finding the second largest element without the sorting. So these are common interview patterns. Now, why patterns matter? When beginners start DSA, they try to memorize solution, they solve and LeetCode problems unlimited, but that does not work. Instead, focus on the patterns. If you understand how to track a maximum element, you can solve 20 different problems. If you understand frequency counting, you can solve duplicates, unique, majority, anagram problems. So today we are training our brain. So this is the first pattern, track maximum and minimum. This is the simplest and most important pattern. The idea is very simple in this. While traversing the array, we keep updating the best value. Now, instead of just theory, let's see it in the code. Find the maximum. And I have this array and a function find the max. In this parameter, I get an array 42917. Now, first, let max equal to minus infinity. And first, I create a function. I initialize a maximum variable as the negative infinity, because any number in array will be bigger than this. Then go through the array for let I equal to 0, I smaller than array dot length I plus plus. Simple. And I update the max value every time. If maximum value is smaller than the array of I, then update it with the array of I every time. And at the end of the just return this maximum value, return max. And let's run this node with find max. So yes, I get the 9 as expected. The answer is the 9 here. So here we'll only loop once, means time complexity is the big of 1, and we use only one variable, so space complexity is also big of 1. And this is a simple problem, and you can also find the minimum value in this. Just replace this minus infinity to plus infinity, and reverse this greater than to smaller than, and check and update the values. Now second value here is the second pattern here is the count frequency. This pattern is extremely important. Many LeetCode problems are based on the frequency. Instead of using the nested loop, we use an object. And so let's move to VS Code and try to run this. So here I have a function count frequency. It takes the as array as a parameter. So let frequency object, a normal object, JavaScript, nothing. I'm not using any hash map, hash set, just a normal object. Start a for loop, let I equal to 0, I smaller than array dot length I plus plus, and let value equal to ARR of I. So I extract the value of ARR of I, and if frequency of value has any value, then increment this value plus plus, else frequency of value equal to 1, and return the frequency. So here we create an empty object frequency, and now we traverse the array using the for loop, and from I equal to 0 to array dot length, and for every element, if it already exists in the array, in the object, increase the count for it. Means we can also access the value of an object by using this square bracket also, and otherwise set the value by 1, and that's it. And let's run this node count frequency. I get 1 is 3 times, 2 is 2 times, 3 is 1 time. So this is also run in the single for loop. So time complexity here is the big of n, and space complexity is the big of n, because object may store all the elements. Means if an array does not have any duplicate, only single value 1 2 3 4 5, then it store the up to the n values. That's why space complexity here is the big of n. Now this pattern is used in the contains duplicate, single number, majority element, anagrams, and many more. The LeetCode problems and in the patterns. Next one is the prefix sum. Prefix sum means running sum. Means we keep adding element and store the cumulative result. So let me show you. I have a, where is the prefix? Yes. So I have again a simple array 1 2 3 4, and a function prefix sum has the value array. Its strict parameter as the value. So let result a blank array. Let sum equal to 0 to store the track the sum. Now start a for loop. For let I equal to 0, I smaller than array dot length I plus plus. Every time count the sum. Sum equal to sum plus ARR of I. A normal means calculating the sum of an array. Now every time push this sum into the result array, and in last return the this result, not the sum. And here we keep a running variable called the sum is equal to 0, and every time we add the current element into the result array, then push into the result array. This help us when we want the fast range sum query. Means we create a result of the sum of the all the arrays. We will study this deeper later, but today just understand the idea. I'm not going into the deep in this prefix sum topic, because this is already a wide range topic. So let's run this code. Node prefix sum. I get 1 is for the 0th index, 1 plus 2 3, 3 plus 3 6, 6 plus 4 10. As expected, 1 3 6 10. Now why prefix sum is powerful? Because it has a fast range sum queries. Mean reduce the repetitive calculation. We do not need to calculate again and again, and used in many advanced problems. Now practice problem. Find the second largest element from an array, and ideally don't the means now important question is how to find the largest without sorting, because there is a condition don't sort. And now beginners make mistake. They sort the element and take out the second value from the last means n minus 2 index value. But sorting takes the big of n log n time complexity. This is the very big means this is very big time complexity. We can do it in the big of n by smart way. So let's write here. I have a random array 4, 2, 9, 1, 7, and I have a function find the second largest, and it's take the array as the parameter. So start with select largest element is the minus infinity. Always right here means whenever you want to find the maximum element, minimum element, always use the infinity value for that. If you are finding the largest element, use the minus infinity. If you find the minimum element, use the plus infinity, means normal infinity. Now largest element is the minus infinity, and second largest is equal to also minus infinity. Now let's start a for loop. For let I equal to 0, I is smaller than array dot length I plus plus every time, and let current equal to array of I, means we take out the this array of I index element, so we are not writing this array of I again and again, this square bracket. Now check if current value is greater than the largest value, then update it. Largest value will be now is the current, and also update the second largest, means we find the largest value, so largest value is now updated, and second largest value is now the largest value, the previous largest value, right? And right here else condition means if current value is the smaller than the largest value, maybe it is greater than the second largest value. For that we have to check whether the current value is greater than the second largest or not. If it is, then update the second largest will with the current element, and also mark here and with the one more condition that says current is not equal to largest, means we have to find the second largest, and not be like both largest and second largest will be same. So in last we have to return second largest element from this. If current is greater than the largest, then all largest become the second largest and current becomes the largest value. Else if current is the smaller than the largest but bigger than the second largest, we update the second largest value with the current. This run in the big O pan because only one for loop runs till the array dot length, and big O one space complexity because there is no array form array I am building or any object I am creating, so no sorting need here. So let's run this node find second largest, I get 7. And what about the largest element, largest and second largest? Let's say largest value is in 9, second largest is the 7. So I have also here a one table here. This code is same. First current value is the 4. Second, so current value is the 4, second largest and second largest both are infinity initially. Largest value we update with the 4, second largest is updated with the largest value, means minus infinity again. Now second value is the 2 here, so we check whether this is greater than, no, but it is greater than second largest, yes. 2 is greater than minus infinity, yes, so we update the value here. Now current here is the 9, so largest value is the 4, 9 is greater than 4, so we update it, yes. Now second largest value is take the value of largest value, so we copy this 4 here into the second largest. Now next one is the 1, 9 is greater than 1, 1 is greater than 9, no, so skip it. Now comes to second largest, 1 is greater than 4, No. So again skip it. Now current value is the 7. Largest value here is this 9. 7 is greater than 9. No. It falls this if condition. Now second largest value, whether the current value is greater than second largest, 7 is greater than 4. Yes. So we update the second largest value and return the second largest. As expected, our output becomes this 7. So count frequency I already covered in this count frequency, this one. Now key takeaways, and today we did not solve big problems, I know, but we built the important foundation: tracking values, counting the frequency, understanding the prefix sum, and avoiding the unnecessary sorting. These are small habits, but they build the strong logic. Today was very important. If you understand these patterns clearly, LeetCode problems will start feeling easier to you. Don't just copy the code, pause this video, write the code yourself, test with the different inputs. In the next video, we will apply these patterns to real LeetCode problems. And if this video helped you, like the video, share it with your friends, subscribe to JDCodebase. We are building the strong DSA step by step. See you in the next video.